This is for Year 12 methods. It comes out of 5i. It's question number 7. Carbon-14 is a radioactive substance with a half-life of 5,730 years, which means that after 5,730 years it will have half the mass that it started with. Okay. So if I know that the mass will be the original E to some K times T, I can then use this idea of the half-life to work out what K is. Let's say I originally start with 100 units or grams. Then when it's at its half-life, that is T equals 5730, the mass will equal 50, because that's what a half-life means. The 100 will become 50 after that many years, because that's what its half-life is. So 50 equals 100 e to the k times 5730, which means a half equals e to the k times 5730. And if I turn this into a logarithm, 5730k equals log base e of a half, which means k equals 1 on 5730 log base e of a half. If I want to turn this into a log base e of 2 to the negative 1, the negative 1 can come down the front, and that's another expression for k. Okay, now I need to know how old is it if it's 40%? Well, if it's 40%, m now equals 40. Because if I start at 100%, now I'm 40%. What does T equal is what this question is. So I know that the mass is going to equal 100 e to the minus 1 on 5730 log base e of 2. So 40 equals 100 e to the minus 1 on 5730 log base e of 2 t. Sorry, there's a t there. So 0.4 equals e to the minus 1 on 5730 log base e of 2 t. And I'm going to use a calculator to solve that. Okay, so I've entered what k is, and there's my expression for k. I've got 0.4 equals e to this expression for kt, and I'm going to interactive advance solve. Do that again, interactive advance solve, and solve for x in my particular case, and there's my value for x, which is t equals 7574.65 years old.